grade 11s, welcome to another series of iCamp lessons. So today we'll be covering your trigonometric identities. So basically this lesson will be covering your trigonometric identities. To understand how they work, we'll also cover your reduction formula. We'll also try to cover your proof of identities. And we'll see if we can get to find the general solutions and solving trigonometric equations, right? So we'll start at your trigonometric identities. So take this lesson as your intro to trigonometry for grade 11, right? Just before I forget, if you are seeing this on YouTube, just make sure you subscribe, you like, comment, and share the video. Thank you. We really appreciate your support. Great. So let's start with your trigonometric identities, right? So the first thing that I'm going to try and do is I'm going to take you on a recap, right, on your trigonometric ratios. So we can just do a recap of your trigonometric ratios, right? Your trigonometric ratios, right? So we have three trigonometric ratios for the purposes of this or the purposes of your curriculum. The most important ones should be your sine, your cosine, and your tangent, right? So it's your sine, right? It's your sine, which is usually called, you can even call it sine. And then you have your cosine, right, which you can also represent it as your cos. And then you have your tangent, right? You have your tangent, which is often called your tan, right? So how can we represent this? So if, say, for instance, you are given a triangle, right? So, for instance, you are given a triangle, and then you have your theta, you have your alpha here, right? So basically what you are going to do is, you can always call this, this is your hypotenuse side, this is going to be your opposite side, and then this is going to be your adjacent side, right? Or what we can do is, in terms of Pythagoras theorem, we can just represent this as your y, we represent this as your x, right? And then we represent this as right. So from your SOHCAHTOA, the way in which we are going to represent this, from your SOHCAHTOA, if the first angle, or we are looking at this angle, right, your theta. So the way in which we are going to represent the trigonometric ratios is, if you have your sine theta, your sine of theta is going to be your opposite over hypotenuse, right? So in this case, your opposite side is going to be your y, right? It's going to be your y divided by your hypotenuse side is going to be r, right? And then your cos of theta is going to be your adjacent side over your hypotenuse. So your adjacent is x, and then your hypotenuse is r, right? And then now your tangent, right? Your tangent, or your tan of theta, in this case it's going to be your adjacent side, your tangent is going to be your opposite over adjacent. So it's going to be your y over x, right? This is in terms of theta, right? Now let's see if this now is for alpha, right? So this was for theta, right? This was for when the angle is theta. So now let's say if now it's alpha, right? So now your sine of alpha is going to be what? So remember, now this is the angle that we are looking at, right? So this is the angle that we are looking at. So in this case, your sine, your hypotenuse still remains the same, but now your y changes, and then your x also changes. So now your y is no longer the opposite side. It's no longer your opposite side. It's your adjacent side if this is the angle, and then x is going to be your opposite side. So in this case, you are going to have sine alpha is equals to your opposite side is going to be your x over r, right? And then you still have your cos of alpha, and your cos of alpha is going to be your what? Your adjacent, so it's going to be your y over r, right? And then the last one being your tangent of alpha being what? Your adjacent, your opposite over adjacent, so it's going to be your x over y, right? So this is how we find your trigonometric ratios, right? This is how we find the trigonometric ratios, and they are usually applicable for right angle triangles, right? They are usually applicable for right angle triangles, right? Great. So now what we are going to do, right, before we can start diving into, so now we're gonna go to the next page. We already understand the basics of your trigonometric ratios, right? So now we are going to go and dive, right? But before we can learn identities, right? Before we can learn identities, it is very important that we understand the difference between an equation and an identity, right? We have to understand the difference between your equation and your identity, right? So this is what we need to understand, right? So we are going to start with your equation, right? So we are going to start with your equation. So if we start with your equation, right? So an equation is true only for specific values, right? So your equation is going to be true only for it is going to be true only for specific values, right? So take for an example, you have if you have 2x plus 3 equals to 7, right? So it means that you are going to have 2x is equals to 7 minus 3. If you take 7 to that side, it's going to be 7 minus 3, and this is 4. And then if you divide by 2, you divide by 2, you'll be left with x is equals to 2, right? So it means that this equation, right, this equation will only be true, like 2x plus 3 will only be equals to 7 if x is equals to 2, right? So that's the difference, right? And then however, for identities, an identity, it will be true for all permissible values or for all possible values, right? So if you talk about your identity, right, so your identity will be true for all permissible or possible values, right? So for example, if you have an example of an identity would be your a plus b all squared will be a squared plus a, this will be 2ab, right, plus b squared, right? So this will work for all possible values of a and b, right? So this will work right for all values, right, for all values of a and b, right? So that's the difference between an equation and an identity, right? So now let's go ahead and try to look at this, right, and at the type of identities, right? So we are going to go ahead and look at your first identity, right? We are going to go ahead and look at your first identity, right? Your first identity, right? Your first identity, which is gonna be your tan of data, right? So now what we are going to be required here, we are required to derive, right? So we need to be able to know how to derive this, right? We need to be able to know how to derive this. We need to be able to know how we derive what? How we derive your tangent of data, right? So it's gonna take us back to our triangle, right? It's gonna take us back to this triangle, right? So take for instance, right? Take for instance, you have a triangle, right? We are going to do the same thing. So we are going to have data and we have right angle here, and then we are going to have your x, y, and r, right? So your sin theta is going to be the opposite, so it's going to be y over r, and then your cos of theta is going to be your x over r, and then your tan of theta is going to be your y over x, right? So you have three trigonometric ratios. So what we are trying to prove, or what we are trying to get to, is how we got to tan, right? So if we take both sine and theta, right? So if we are to take both sine and theta, right? So if we are to divide sine by theta, right? So if we divide sine by theta, so now that's what we are going to do. We are going to divide sine, going to say sine theta divided by cos theta, right? In this case, what is sine theta? Sine theta is the same thing as y over r. It's y over r, right? And then what is cos of theta? Cos of theta is x over r, right? So in simplest terms, we can just write this as still x. It's gonna be x over r, right? And then from here we can just say y over r divided by x over r, right? And then if we simplify this further, we are gonna have y over r is equals to y over r If we change the division sign, it becomes multiplication, and then the numerator becomes the denominator, and the denominator becomes the numerator. We'll have x over r, right? And then from here, we are going to be left with, if we take a look here, your r and r will cancel, and then you will be left with what? With y over x. With y over x. So let's just take this a little bit up. Yeah. So now this is how we prove your tangent of theta, right? So this is how, not prove per se, but this is how we derive it, right? This is how we derive it. So you still have your sine theta over your cos of theta. It's still sine of theta over your cos of theta. So this is how we derive it, right? If you look at here, right, this is the same thing as your sine of theta, your y over x is the same thing as tan, right? So that means that your tan of theta is indeed equals to your sine of theta over your cos of theta, right? So this is how we derive our first identity. This is how we derive our first identity. This is how we derive our first identity. So here, I believe we should have written this is how we should have written your sine of theta over your cos of theta. Right, so this is how we derive it. This is how we derive it. Right, so now we have derived the first identity, right? Or we have proven the identity, right? So I think from here, what we need to take note, right? What we need to take note of, right here, is if you do have your tan of theta, which is sine of theta over your cos of theta, right? In this case, your cos of theta or your cos of theta cannot be equals to 0 degrees or 0. Let's just say 0, right? It cannot be equals to 0. Right, so now let's look at the second identity. So the second identity is what we call your Pythagorean identity, or your Pythagoras identity. So this is your second identity, right? So your second identity will be your Pythagorean identity, right? Which is given by, it's mostly given by, it will be your sine squared theta plus cos squared theta is equals to 1. Right, so this is what the identity says. It's your sine squared theta plus your cos squared theta, right? So in order for us to derive this, right, right, we'll derive it using a unit circle, right? We'll derive it using a unit circle. So a unit circle is a circle with radius of 1, right? So let's do that. So we're just gonna draw a Cartesian plane here, right? And then we'll have our circle here. Right, this now looks more like a circle, and then you have your x, you have your y, and then here this is going to be your origin, and then here you are just gonna have your radius of 1, right? So you are going to have your r equals to 1, right? And then this we can call it a point, and it's going to be point P, right? It's gonna be point P, right? And we can call this point P, it's going to be x and y, right? So if we were to draw now a right angle triangle here, if we were to construct a line here, this would make it a right angle triangle, right? And this now would be your y, and this would be your x, right? So this now will form a right angle triangle, right? It will form a right angle triangle. Right, this will form a right angle triangle, right? So now if we wanted to know the coordinates of P, right? If we wanted to know the coordinates of P, the coordinates of P in terms of your sin theta, right? So this will be your theta. So if we wanted to know the coordinates of P in terms of the coordinates of P in terms of your trig ratio, right? In terms of your trig ratio. If you wanted to know that, right, if we look at here, right, we are going to start by, we are going to say your cos of theta, right? So if you have your cos of theta, excuse me, your cos of theta is going to be, what is a cos, right? A cos is represented by adjacent over hypotenuse. So in this case, it's going to be x over r. However, r is equals to 1. So this is going to be x over 1, and this is going to be x. Therefore, you will have your cos of theta. You will have your cos of theta is equals to 1. Right? And then now let's look at your sine, right? Let's look at your sine. So if you have your sine of theta, so your sine of theta is going to be your y over r, and then your y is just y, and then your r is equals to 1, then you will have your y. And therefore your sine of theta is going to be equals to y, right? So now you have P, which is x and y, right, which can also be written as P is equals to your cos of theta, right, and your sine of theta, right? So now what we have is a unit circle right now represented by your unit circle represented by P as cos theta and sine theta, right? So in this case now we can just come here and update it, right? And we can say that your y is the same thing as your y is equals to your sine of theta, and then even your x, right? Even your x is gonna be equals to your x cos of theta, right? And then if we take the square root, right, if we go back in that triangle, right, in that triangle, and we take the Pythagoras theorem, right, in the same triangle, right, if we take the Pythagoras of the units of the triangle in that in that unit circle, right, if we take the Pythagoras of the unit of the triangle of that triangle, right? Now it's going to be your r squared is equals to your x squared plus your y squared, right? But what is r squared, right? R squared is equals to 1. And what is x squared? X squared is equals to your cos. This is just 1 squared. Your cos, that's going to be your cos squared theta plus what is y squared? Y squared is going to be your sin squared theta, right? If we substitute, right? So if you just want to see it properly, it's just going to be your sin theta squared plus, it's supposed to be cos theta. So it's cos theta squared plus your sin theta squared, right? So now it's going to be your 1 is equals to your cos squared theta plus your sin squared theta. Therefore, this can also be written as your cos or your sin squared theta plus cos squared theta equals to 1. So basically, this is how we prove this identity, or how we get to derive this identity, right? So basically, that's how we get to derive this identity. So this should be y, right? Great. I hope that makes sense. So you derive it from what? From the concept of a unit circle. You derive it from the concept of a unit circle. I'm not sure why it's doing this. Right. So this is how we derive it. Right. So we are going to construct a unit circle, right, and find the coordinates of P in terms of your trig ratio, right? We're going to find the coordinates of P in terms of your ratio, and then from there we are going to then try and solve, right? From there we just try and solve. This is the first one. First, we should be using this color. Right. So now we have gone on to prove the two trig identities, right? So we have gone down to prove the two trig identities, right? So now from here we can just go on and try to deal with questions that may arise from these two identities, right? We can go on to try and see how we can solve problems from that. So if we look at this example here, right? So this is an example where we have to apply our trigonometric identities, right? So the example that we are given here is we need to find, right? So we need to find sin theta. We need to find sin theta provided, right, or if cos theta is equals to 4/5, right? So a trigonometric identity that is easy for me, or that comes to my mind, right? A trigonometric identity that comes to my mind when I have to solve this is your cos of squared theta plus your sin squared of theta is equals to 1, right? Remember, what we want is your sine of theta, right? So what we want is your sine theta, and we can get sine theta from sine squared by applying the square root, and we do have cos squared, which means we can just solve, right? So what we are going to do is, from this equation, we are just going to say your sine squared theta is going to be 1 minus your cos²θ, right? So your cos squared, I can just put 4 over 5 all squared. So this is going to be your sin²θ is equals to 1 minus, what is my cos²θ? So I can just say 4 over 5 all squared, right? So this can just be 4 over 5 all squared. Great. So now I have my sin² is equals to 1 minus your 4 squared is 16 over 25, right? And if you punch your calculator, or you can simply say sin² is equals to your 25 over 25 here minus 16 over 25, and you have your sin² is equals to 16 minus 25, 25 minus 16 becomes 9 over 25, right? And then from here, what I can do is I can just apply my square root, right? I'll just apply my square root, both sides, and then I have my sin θ is equals to square root, it's going to be 3 over 5, which is can be plus minus, right? So this will depend on your quadrant, right? Which we will cover shortly, right? So the study of quadrants is what we will cover very soon, right? But this is how you get your answer, right? So now what I am going to move you to is your part 2, which is your reduction formula, right? So we will cover the fullness of these examples, or everything, as soon as we are done. We'll start practicing with more class problems and more question papers, but for now we are going to move on to the next chapter, which is using your reduction formulas or your cast diagram. Right, so if we look at your reduction formula, right, so the purpose of having a reduction formula, or the purpose of the study of reduction formula, it's not really a study. The purpose of concept of a reduction formula is to allow us to be able to rewrite angles which are larger than 90 degrees or which are greater than 90 degrees in terms of acute angles, right? So what we are trying to do is we are trying to write angles that are far greater than 90 degrees to be in terms of acute angles. So your acute angles would be your angles between 0 and 90 degrees, right? So the purpose or the idea is to rewrite, we are trying to rewrite angles greater than 90 degrees to be in terms of acute angles, right? So it's very important because acute angles would be your angles that are between 0 and 90, right? And the best way in which we can do that is by explaining or going through this cast diagram, right? So we will just go through a cast diagram right now. So a cast diagram, it tells us where in the Cartesian plane are we when we consider our angles, right? When we consider our angles. So yeah, so let's go ahead and see how we can best explain that, right? So here you are going to, let's just change the color. We have your blue, right? And then that's fine. So here you have your 90 degrees, and then here you have your 180 degrees. Here you have your 0 degrees, and you have your 360 degrees, and then here you will have your 270 degrees. Right, so the way in which we count, right, at our angles is, say for instance we have a point here. We will count from your x-axis, your positive x-axis going this way, right? So it means that any angle from here, it's going to be 0 plus, right, whatever, right? So the way in which we are going to identify that, or we're going to understand that, is all the angles that are here, right, we can just say theta, right? We can just call it theta, right? And another angle that we'll find here will be your 90 degrees, should be your 90 degrees minus theta, right? Because if we count or if we travel, or we count from here going this side, it's going to be what? 90 minus, and then here it's going to be theta plus or 0 plus. That's why it's just theta, and then from here going that side, it's going to be 90 minus, right? So it means that if you have any angle, here we were supposed to call these, this is going to be your Q1, this is going to be your Q2, this is going to be your Q3, and this is going to be your Q4. It's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Right, perfect. And then here it's going to be, the first one, it's going to be your 90 degrees plus theta, right? Theta, it could be anything. It's going to be 90 degrees plus theta. And then another angle here, it's going to be 180 minus theta. 180 minus, right? Because if you look at it, it's going to be 90 plus and then 180 minus, right? Because remember, when we count from here going that side, which is in a clockwise manner. No, anti-clockwise. It should be anti-clockwise from 0 to 360. So anything that comes when we are on quadrant 2, anything from here, it's going to be 90 plus, and anything from here, it's going to be 90 minus, right? And then on quadrant 3, you are going to have 180 degrees minus theta, and then you're also going to have 270 degrees plus theta, right? Remember, we are at 180 here, and if we go here, it's going to be 180. No, it should be 180 plus. You see the importance of logic, right? That's the importance of logic. So it's going to be 180 plus, and this is going to be 270 minus, right? Great. And then at quadrant 4, we are going to have 270. We are going to have 270 degrees plus theta, and we are also going to have 360 minus theta. Right? So if you have any angle, right? If you have any angle, right? If you have any angle that is 90 minus, then you know that angle will be found in quadrant 1, right? If you have any angle that is just theta, it will be quadrant 1. If you have any angle that is 90 plus, it's going to be quadrant 2. 180 minus, it's going to be quadrant 2. And then the same is true, not the same is true, but if you go to quadrant 3, you are still going to have 180 plus and 270 minus, 270 plus and 360 minus, right? Now, in terms of the reason why this is called a cast diagram, we'll see shortly. Right? In terms of the trigonometric functions, right? In terms of the trigonometric functions, when you come to quadrant 1, right? When you come to quadrant 1, your sign, right, is going to be positive, right? Your sign is going to be positive, your cos is also going to be positive, and tan is going to be positive as well, right? Meaning that all your trigonometric ratios are positive at quadrant 1, right? And then when you come to quadrant 2, only sine is positive, right? So your sine is positive, however your cos is negative and your tan is negative. So only sine is positive here, right? And then in this case here, you will have your tan is only the positive one. So your sine will be negative, your cos will be negative, however your tan will be positive, which means that only tan is positive, right? And then here in this case, only cos will be positive, right? So your sine will still be negative, your cos, however, now will be positive, and then your tan will still be negative, right? And then here it's only cast, I mean your cos, right? Hence this is normally referred as your cast diagram, right? It's normally referred as your cast diagram, right? So we can look at an example of how we apply it, but basically this is how we define our cast diagram. So this is what you would call your cast diagram, right? This is what you would refer to as your cast diagram, right? This is what you would refer to as your cast diagram. So this is very important because without the understanding of this, then we won't be able to solve any trigonometric ratios. Any trigonometric ratios that require us to apply your reduction formula, right? So that's very, very, very important, right? It's very important. And now to complete this, right? To complete this and to have a full idea of this, right, your reduction formula, now we will consider what we call your core functions, right? We'll consider what you call your core functions. So your core functions, we will need your special triangle, right? So now you will have, we'll just go through your core functions, right? So your core functions are usually sine minus, sine plus, 90 minus, 90 plus, 90 minus. So those are your core functions. You usually find them on 90 plus, 90 minus, right? So basic formula of your core functions is if you have your sine, right, your sine of 90 degrees minus theta. So your sine of 90 degrees minus, so 90 minus is on quadrant 1, right, which means that whatever answer is going to be positive. However, sine becomes cos, right? Excuse me, your sine becomes cos, right? So it transforms into becoming a cos, right? So this is very important. This is very important, right? And then another one is if you have your sine, right, of 90 degrees, if you have your sine of 90 degrees plus theta, right? So where do you find your 90 plus, right? So you'll find your 90 plus in quadrant 2. So 90 plus is in quadrant 2, right? And we are talking about sine, and sine is positive. However, your sine now, your sine changes, right? Your sine changes and it becomes what? Your cos. So it will become cos theta. It will become positive cos of theta, right? And then now let's look when we are talking about cos of 90 minus theta. It's 90 degrees minus theta. So if we look at this, right, where is 90 minus? 90 minus is in quadrant 1, right? 90 minus is in quadrant 1. And how is cos in quadrant 1? It's positive. So cos now will change into becoming what? It will become a sine of theta. Perfect. And now we are going to look at the last one, which is 90 degrees plus theta, which is equals to, how is cos in 90 plus, right? So 90 plus is in quadrant 2, right? And how is cos there? Cos is negative, right? Which means that whatever answer we get, it's going to be what? It's going to be negative. But how does cos change? Cos changes to become a what? A sine. Becomes sine minus, minus sine theta. So these are your core functions, right? These are very, 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 very important, right? These are very, very, very important, right? So what we can do is actually to try and see if we can do at least one example with this, right? So let's just go ahead and do one example. Now, before we go into our example, we need to also talk about your special triangle, right? Which is also very important. We also need to talk about your special triangle, right? We also need to talk about your special triangle. So this would be represented by something looking like this, right? So your special triangle is your 60, your 30, 60, 90, excuse me, triangle. So if you have 30 here, you have 60 here, this is gonna be your 1. This is gonna be your 2, right? And this is gonna be your root 3, right? So this is a special triangle, right? It's very, very, very important. So for example, if you were to be given your sine of, let's just say your sine of 30 here, your sine of 30 is going to be opposite over hypotenuse, right? Your opposite side now, it's going to be 1 over 2, right? And now let's say we want a cos of 30 degrees, right? Your cos of 30 degrees is gonna be your root 3 over 2, right? So this is what we call a special triangle. It's a very important concept. It will also help you in solving such problems, right? So you have that. You have that. So this is what we have. And then now let's just look at the other one. So if we were talking about your sine of 60 degrees now, so your sine of 60 degrees will be what now? Your sine of 60 degrees will change because now it's no longer 1 as your opposite. Now it's going to be your root 3 over 2, and your cos of 60 degrees is going to be what? Your cos of 60 degrees now, it's going to be adjacent of hypotenuse, so it's going to be the inverse, right, or the opposite of what sin θ was. So this is going to be 1 over 2, right? It's usually useful for explaining this, right? So we can also look at tangent now that we do have your special triangle. So we can look at tangent as well. So your tangent of 30 degrees, your tangent of 30 degrees, what is tangent? It's opposite over adjacent. So it's just gonna be root 3, and your tangent of 60 degrees still opposite over hypotenuse, so it's just gonna be your 1 over root 3, right? So this is how we use our special triangle, right? Now that we have covered everything we need to know about your identities and your reduction formulas, we can go ahead and see how we can solve problems, or one of the problems, right? Right, so if we look at the example, right, so we have to simplify without the use of a calculator. We have to simplify the following without the use of a calculator, right? So we are gonna go back. We're gonna go back to our cast diagram, right? So sin 180 minus, right? So sin 180 minus. If we go back to our cast diagram, 180 minus is in quadrant 2, right? And how is sin in quadrant 2 is positive, right? So 180 minus becomes what? It will become sin x, right? So this will become sin x because it's in quadrant 2, and 180 minus is positive in quadrant 2. Now we look at cos 360 minus. So what is cos 360 minus? Cos 360 minus, if we come here, we look at where is 360 minus. 360 minus is in quadrant 3, right? Is in quadrant 4. And how is cos in quadrant 4? Cos in quadrant 4 is positive. So it means that we are also going to have cos of positive, right? Now we have a special one here. You have cos of 90 minus. We said cos of 90 minus is what? Is a special function, right? It's a special function. So this is cos of 90 minus, which is going to be positive sign, right? Because 90 minus is here and everything here is positive, so it's going to change sign and become sine, right? And then you also have cos of 180 plus, right? So what is cos of 180? Where is 180 plus? 180 plus is in quadrant 3. And how is cos, right, in quadrant 3? It's negative. So this will now become negative, right? So we can go ahead and solve this. So you have 2, right? And we already said that this is going to be positive. So you have 2 sine x times what is 360 minus. 360 minus is in quadrant 4. And in quadrant 4, cos is positive. So this is going to be cos positive. Cos x. Remember what we said about reduction formula. The idea is to represent angles that are greater than 90 degrees in terms of acute angles, right? Over your cos of 90, we did say that it's going to change sign. It's going to change and become sine, and it's going to be positive sine. Here we are going to have minus what? Cos x, right? And then if we look here, we have something common. You have sine and sine, which is going to cancel, and you have cos and cos, which is going to cancel. And now you have 2 divided by -1, which is equals to -2, right? Fairly simple, fairly simple. Now let's look at another class problem. right? Let's look at another class problem. So here we still have the same thing. So let's just take our cast diagram and take it that side so we avoid turning, right? So we can just copy our cast diagram. We can still bring it here so that we see what we're talking about. We can come back here if we want to, but we can also paste it here as well. Great. So now we have 180 minus. So the first thing that we look at is 180 minus. Where is 180 minus? 180 minus is in quadrant 2, right? But we are dealing with tan. How is tan in quadrant 2? Tan in quadrant 2 is negative, right? So we are going to say negative tan x, right, times, now we have cos, right? We have 360 minus x. So 360 minus x is in quadrant 4. And how is cos in quadrant 4? It's positive. So we are just going to have your cos of x plus, now we have a cofunction. We have 90 plus, right? Where is 90 plus? 90 plus is in quadrant 2, right? We're dealing with cos. How is cos in quadrant 2? It's negative, right? So it means that whatever answer we get, it's going to be negative. So it's going to be negative. Remember, this is a cofunction, so it's going to transform and become sin x, right? And then you have all over. Now you have cos 90 minus. So where is 90 minus? 90 minus is in quadrant 1. We are dealing with cos. It means that whatever transformation will happen, it's going to be positive. So we are going to have positive sin x, right? So it's going to be your sin x times, what is 90 plus? 90 plus is in quadrant 2 here, right? 90 plus x or 90 plus theta is in quadrant 2. We are dealing with sine. How is sine here? It's positive, right? But it changes and it becomes cos. So this will become what? Your cos of x, right? Great. So we are not done, right? We are not done. Remember what is tan. So your tan, remember what is tan, right? Your tan x is the same thing as your sin x over cos of x, right? We did solve this, we did explain this. So that's what we are going to do, right? We are going to also dissolve that. So we are going to have negative into your sine of x over your cos of x times your cos of x minus, because now we have a negative and a positive, and a negative and a positive, positive always comes out, and then you have minus sine x, and then all over you have your sine x times your cos x, right? And then from here you will have your cos x cancelling cos x, right? And then what you will be left with is going to be your minus sine x minus sine x over your sine of x times cos of x. So what is minus sine x times minus sine x minus sine x is going to be minus 2 sine x all over your sine x times cos of x, right? So this and that will cancel, right? And then now we will have our final answer is minus 2 all over your cos x. So we cannot simplify this further than what it already is. So this will be your answer, right? So as you can see, the importance of having your cast diagram, right? It's the same principle that applies here, right? It's the same principle that applies here. Right, grade 11s, thank you for joining in until this far. We will meet when we have to do more questions. We'll have to do more questions. Unfortunately, we could not get into general solutions and trigonometric equations, but we will get to that in the next video. Thank you.